All right, let's get this going. First off, let me say, welcome to Scala Up North. Allow me to be the 7th person to welcome you guys. I know the obvious thought on everyone's mind right now is, thanks, but you are who? My name is Mike Cohen. I am from New York City. Before we go any further, does anyone have any cabbage, tomatoes, throwable vegetables? Great, I'm a tech recruiter. So, I know you're all thinking, whoa. They let a tech recruiter in here? Yeah, they did, and now you're all stuck here until you send me your CVs, so good luck. On a serious note, I've been a tech recruiter for about 9 years. I have 2 focuses in the tech community. The first one is the proverbial DevOps space, CI/CD automation and cloud deployment. Second, functional programming, namely Scala, a little bit of Clojure, Jet, thanks to Jet F#, which may or may not be Walmart soon, and due to a very, very small contingency of JP Morgan Chase, Haskell. So, yeah, I know, it's really weird. I don't know how that happened, but it did. I was actually introduced to functional programming from a buddy of mine who did a short stint at Twitter, left to join Orchard Platform, and tried explaining to me this concept of functional programming. I'm not a coder, I'm not a software engineer, so I had no idea what he was talking about. So he broke it down and was talking about immutability. And he said, well, Mike, think of object-oriented programming as you're building a house. You have a blue house, you have white shutters, you have a red door. 2 years down the road, you want to change the door out to a glass door. So you remove that object, replace it with a glass door. Same situation in functional programming 2 years later. You want to replace it with a glass door, you build a new house. To which I looked and said, that's ridiculous. Why in the world would you ever want to do that? And it took me probably 9 months to wrap my head around, oh, there's actually a use case for just building a new house. So, yeah, I know, it took me a lot longer than it took you, I'm sure. However, as a fellow human, I'm also a spin instructor. I teach about 10 classes a week. I am an avid ping pong player. I will gladly challenge anyone in this room to a game, and I can't imagine any of you, yeah, I got you. I can't imagine all of you right now are thinking about the fact that, oh my God, what a crazy weekend. I was at a tech conference and a recruiter presented to us and beat me at ping pong. So, yeah, there's that. Lastly, I probably know as much about Batman as most of you do about software engineering. Yeah, true fact. So, now the question is, what in the, if you can't read that, it literally says, so what could a recruiter possibly talk about? That's a great question. As I said, I don't code. I don't have a CS degree. I do love math, oddly enough. I'm a curious person. I have a unique perspective, particularly in this market, because I interact with it, but I don't live in it. And I have a very deep network to draw from. So, the first thing I'd like to chat with you about is something that I call Scala's Vestas poisoning. It's a joke on asbestos poisoning, don't worry about it. So, this kind of came about from attending Scala days and interacting with Scala engineers and companies using Scala. Scala's asbestos poisoning is caused from too much insulation. What do I mean? My perspective, particularly from volunteering at Scala days, if any of you were there, I was that goofy guy with the long hair trying to get selfies with Martin, which I succeeded in, by the way. I noticed that you guys had a really impressive sense of community. I also was made strikingly aware of the fact that you guys tended to have a little bit of an inward focus and perspective. Now, it was incredible to see the large group of people come together and try to better the technology and the community using it. However, this community isn't what will or won't determine the future of Scala and its mass adoption. It's those on the outside wanting to get in, those curious how to get in, or those that were at one point in and left for whatever reason. My goal is just simply impart from a perspective, the view of someone outside the community who's been lucky enough to high-five a lot of people living in the community. So, next, I'd like to get you acquainted with your market. It's a joke on it, never mind. I am able to provide a unique perspective, gathering insight both technically and professionally from some of the industry's top leaders in New York City. What really sparks people's interests? You guys are catching on. Through long-standing relationships with my network, I'm able to provide you guys with insight as to not only who's using the tech stack, why they've chosen to use the tech stack, and what they like about it so much. Nice, those are feel-goods. Next, why are people grunting or gulping when they hear Scala? That was a stretch, I know, it's fine. Conversely, I've also heard a fair amount about the features, about the tooling, and the general pain points of people who are currently or previously using the tech stack. Lastly, I would like to create a dotted line to the future. That was a good one. I'd like to be able to share with you guys some of the industry leaders' thoughts as to where they see this tech stack going, as well my own personal opinions as an outsider looking in from a bunch of different perspectives. So, I know the next obvious question is going to be, okay, what's the sauce? So, this is a list of clients, candidates, and friends in the New York City market that I've been fortunate enough to sit down with and more or less interview to get insight as to their personal views on Scala, why their company uses it, some of the things they like, some of their pain points, and general thoughts on the stack. Just for clarification, ED at Morgan Stanley is executive director. I didn't interview some guy named Ed twice about Scala. So, next, outside of that list, wow, this is really, that's zoomed in a lot. It says up top, who uses Scala out there? So outside of the list of people I just mentioned, yes, we all know Twitter is using Scala for everything. We get it. Netflix, TripAdvisor, the New York Genome Center is actually using Scala for some of their DNA sequencing work. Zappos, their e-commerce engine, Verizon, IBM, you guys have already heard about, Dow Jones, a lot of companies in a very varying group of both industry and size. So, why do that's really cool too? Cool. I'm going to tell you what it says. Why do companies, teams, and individuals use the tech stack? The first one actually says it's a common ground for quants and engineers. So in the financial industry, quants are typically using something like R or SAS, a statistical programming language. They may or may not have some experience with Python. However, Python is a fairly easy transition language. It's very read-friendly, it's dynamically typed, so they can usually transition into it. Most engineers in the financial industry are using Java. Scala winds up being a fairly nice go-between for the two. Second, it is less boilerplate. I know Java 8 solved some of these issues, but prior to Java 8, this was a huge issue in the language. Next, conciseness. I think it's pretty straightforward. It means it's less code. Pattern matching, better. We like that. Anonymous functions, again, better with Java 8, but not quite as robust. Actors, are we still together? We are. Yeah, it says actors. Huge advancement for the SOA dealing with concurrency distribution, namely in Akka. Tail recursion optimization, another really, really positive point. Yep, I saw you up there, Owen, that's fantastic. It leads to a more concise nature of code. Ultimately, the less code, the less chance for errors. Type safe, if I have to explain what a statically typed language is, we're in trouble. Immutability, despite what I may have thought, sometimes building a new house is actually the right answer. Better type inferencing, this goes back to the same thing. If we don't have to annotate all of our types, that means we are coding less. That means there's less of a chance for errors. Now, up here you'll see this is in yellow. All of these are double-edged swords. So in interviewing people, some people said, oh, this is such a great advantage, I love this. Some people said, oh, this is terrible, I hate this. I'm going to talk about both sides of all of these. So Akka streams and microservices. We've seen a lot of companies moving from like these monolithic systems to a more efficient and continuously deployable model using microservices. iHeartRadio actually is a great example of this. Earlier this year in February, I believe, they went from a huge Java service system to microservices, and the exact reason obviously is to make it continuously deployable into their system. It was great for them that Akka was straight out of the box cluster solution. They didn't need to set up or build this complex cluster infrastructure. And yes, with Akka Streams, it's reactive programming and it's significantly more powerful. You're now able to treat actor messages as inputs and outputs to functions with type safety. That's awesome, so I'm told. However, the high level of customization and abstraction becomes like a double-edged sword. If you're not both feet in the water to the tech stack, this can be fairly overwhelming, and as an engineer, you can actually lose development efficiency due to the mental cost. I equated this to the first time when I was a kid, and I looked at a soundboard because I was convinced that I was going to be a DJ because I could tap my foot to the beat, and I looked at this soundboard and was totally overwhelmed, right? I came from a world of volume and balance and fade, and now there's 100 knobs in front of me, all that have a unique purpose that a DJ would look at and go, are you kidding? That's the gain, that's the level, all of these make sense. But as someone getting into this, it was totally overwhelming and taxed me too much, and as you can guess, I'm not a DJ, so that didn't work out. Next, the compiler. Again, a lot of varying opinions on this. Most not good. The compile time is slow. We know this. It's true across the stack, right? For most people, it's like 3 to 5x of what it would be for Java. However, if you have a huge code base, Morgan Stanley has 2 million lines of Scala code. If you have a huge code base, or you are not specifying the return types, this number can actually get up to like 50 to 70x fairly easily. Second, under the hood, the compiler, I've been told, is difficult to comprehend. That's scary for many programmers, right? They don't actually know what the compiler's really doing. On the flip side, some people love that it's a JVM compiler. They love working with IntelliJ. So it's a bit of preference, it's a bit of environment, it's a bit of discipline, obviously, with documentation. I do believe that some of this will be cured with Dotty, or could be cured with Dotty. I can't obviously speak to that yet. Sweet, implicit conversions. Yeah, I know, someone always laughs when you say that word. Like most tools or coding practices, they can also be a double-edged sword. When they're used correctly, they're fairly useful, right? Unfortunately, they tend to be overused, particularly when you're in the financial industry and dealing with econometricians. They have no qualms about throwing in implicit conversions anywhere and anytime that they see fit. This is obviously an issue down the road at compile time. Next. Abstraction, the Rube Goldberg machine. Pluses. You can write very complex code if a situation or need arises. Cons, you can write very complex code even if the situation doesn't arise. The obvious plus is the more abstraction, the more pure declarative the code you can write is. The problem is it makes it fairly difficult to deal with in the future on 2 levels. One is someone else trying to read your code. 2, it's difficult for engineers to appreciate the runtime costs of their code. Next, blend of OO and FP, sweet. That's object-oriented and functional programming. Both sides of this coin are fairly obvious, right? But again, something that will need to be more clearly defined in the future. Interoperability, great. Jala, not great. JVM, it's great. JVM, sorry, the next one's community. It's great that we can use all of our favorite Java libraries and make adopting it in the enterprise a lot easier. However, I've been postured by multiple people as to whether JVM is in fact the weakness of the language. Whether it's our reliance on it, whether it's the high memory hunger, or whether it's its tooling. Next, community. All right, so this is gonna hurt a little bit. I'm not calling your baby ugly, but I just want you to hear me out here. The reason this is a plus and a minus is I've honestly gotten mixed feedback as the Scala community as a whole. So while being an accredited community, backed by a stable and trustworthy company, thank you Lightbend, there's been a bit of feedback I've received that the community does tend to be a little bit insular. Oh, 5 minutes, thanks. You can just yell it out, it's totally fine. The community tends to be a little bit insular, which unfortunately comes across as a little bit of elitism. I know no one here is an elitist, but it comes across that way, right? Elitism is like ego. Without any of it, it's kind of hard to assert yourself and have a sense of community. With too much of it, it's hard to build that sense of community beyond those who share your knowledge or understanding or views, something to be mindful of. Last one is talent, correct? Good. This isn't always actually on the forefront of people's minds. If you're a software engineer and you're not necessarily responsible for hiring or firing, and you're not in a really, really lean environment, you probably don't think of this too often. But it's a double-edged sword, right? First off, really hard to find quality Scala engineers. So all of you, give yourself a pat on the back. That's awesome. Until you're in a shop that's running too lean because you can't find any quality Scala engineers. So it's great until you're working 14 or 18-hour days. Not as fun at that point, right? On the good side, it does add a certain level of credibility and standards to the engineers who are working in the Scala space. There's a high bar of entry due to its complexity and its need for computer science fundamentals and mathematics. I'm going to discuss this a little bit more at the end of the presentation, but this will ultimately be a big reason for the mass adoption of the Scala tech stack or its ultimate failure. That sounded really bleak. Of course. This says we love it, but... So these are all the things that in talking to people, they said, yeah, we like it, we use it, it's super important for us, but... Then following that but was usually a longer list of things than the things before the but. So, first one is, too broad, it's too much. I'm sure you guys have heard this, I'm sure you've seen it in some degree. At some point, you can't be everything to everybody. You can be everything to somebody, or something to everybody, but you can't be both. I'm not gonna repeat that. Next, ramp up time. There's not a whole lot we can do about it. We've got Coursera courses, we've got the Scala Foundation, we've got just about any tool that we can do to try to make this an easier transition we're doing. It's just not easy. If you're used to imperative programming and you come from an object-oriented world, you look at problems and go, oh, I know the answer, but I can't do it because it's object-oriented, so I'm gonna literally put the right answer over here and try to come up with a different right answer. That's frustrating. I don't know that. I hear it's frustrating. Compile time, I don't need to talk about this anymore. It's slow. Hopefully it's not going to be as slow. Transpiling. This goes back to those econometricians, right? They're using R and SAS. And one of the things I've heard, particularly from the guys at Morgan and at BlackRock and Millennium, is it would be great if we could compile native languages. We may be able to get these guys to do a little bit of Python here and there. There's no way that they're going to be doing any Scala. I don't know if any of you have ever spoken to a quant or a strat at a big investment bank. They're not super open to changing what they're doing. So that's one downside. Two, SBT. That's okay. So ready. I've heard it referred to as Scala build tool, followed immediately by a fairly defeated look. Or I've heard it referred to as simple build tool, followed by a loud and exaggerated amount of laughter. So it's really complicated to use, right? It's a really tough one to kind of implement. However, your guys' customer and tech support is way better than Gradle's, so you've got that going for you. I think as the language and tech stack continues to grow and get better, this is obviously something you guys are aware of and are working on. Next. First paradigm. What do I mean when I say that? So the general question is like, what is Scala's approach to software engineering, right? Don Syme is always preaching that F# is a functional first programming language, which is great, I guess. Scala is a little bit more in the middle of object-oriented and functional than F# is, but what is its approach? Is it a functional first programming language? Is it an object-oriented first programming language? Or is it object-oriented functional first programming, which is going to be a little tougher to define, right? I believe, from watching Martin's talks at Scala Days, this is something that he's working on in the next 5 years, is kind of synthesizing the modular and functional approach. Next. No debugger. I'm not going to lie, I can't speak to this one way or another. It was just something two people had said, and I figured I'd let you guys know. All right. You're welcome. The next thing says Java interoperability. Now, I know everyone's first reaction is, are you kidding me? But hear me out, mainly because when I talked to the person who said this, I said, are you kidding me? And he explained that it's not an issue working with Java code in a Scala programming base. Fairly straightforward. However, in most of these banks, some of their older Java code still needs to be maintained, still needs to be upgraded, still needs to interact very well with Scala. It is difficult and a headache for them to have the Scala code read in Java. Might be one of Ellison's problems, but at the end of the day, it's a headache for someone I spoke to, and I figured I'd share it with you guys. Cryptic error messages. I've heard this a fair amount, actually. I believe the best it was put was, when something dies in Scala, it dies in a really weird way. It's basically hard, based on the error message, to pinpoint where the problem comes from. And then lastly, it's a complicated language. If you don't know what I'm talking about, look up cake pattern. I actually heard a lot of groaning about this at Scala Days before I even did a whole bunch of research. I heard people like, oh, I can't wait to talk about the cake pattern. It's going to be a great speech, great presentation. And they came out and they were like, I still don't get it. My understanding of this, again, not technical, is that you're able to see the individual strings, but it's fairly ethereal on how to join them. That's as far as I can go technically on that. What I do gather is, conceptually, Scala's a little bit difficult to kind of wrap your head around and master the concepts of. There is a large ramp-up time, and even then, for some people, it's far longer than they're able to commit to. So, we're in India now. This says up there, where is Scala heading? And if any of you watched Martin's presentation, this is what he was talking about. We want to deepen the synthesis of functional programming and modular programming. As I mentioned earlier, the ability to do both within one language while being type safe and statically typed is fantastic, but that synthesis needs to be done in a way that defines the language. This is still an issue for Scala. You can't be everything to everybody. You need to have your use case. Next, improving the connection of Scala with its theoretical foundation and improving the guarantees of type system. I believe both of these will be handled very well with the release of Dot and Dotty. Last, stay simple and approachable. This is interesting. The word stay is the interesting part of this. You see, most of the feedback I've gotten is that Scala's not really all that simple and certainly not approachable if you've never done it before. However, maybe this is being dealt with in Dot and Dotty. If it's not, I think it'd be fairly important to find a way to make the language more simple and approachable for the non-Scala functional programmer, just to ensure your longevity and its mass adoption, which I believe is probably the goal of all the Scala engineers sitting here. But certainly one of mine. This says, but where, how much? No, oh, good. That's good. I'm going to speak really quickly. Where are we heading? A couple opinions brought from people who I had spoken to. Some think Swift or Rust could replace Scala. Both languages offer obviously a little bit different approach to the garbage collection, which tends to be people's gripe about the JVM. Declarative programming. There's a train of thought that says the future is going to be 90% business logic, 10% on how we make that work. A, is that reasonable? B, will we allow ourselves to do that? C, if we do that, aren't we kind of creating a hierarchy where there's going to be like really high-end language engineers and then a bunch of worker grunts who are doing the stuff to make the language function? Maybe. I don't know if we'll ever get there. Hopefully. Dotty, pretty self-explanatory. Different Scala compilers. This is a weird idea on how to deal with different use cases. Was instead of creating different languages, create different compilers or toggles to deal with different use cases from different businesses or companies. I know I'm going, I promise.